Okay, so first, to see that this is a borderline situation, I'm going to multiply this 8.26 times 11.3 to show you the area in square units. So 8.26 times 11.3 equals 93.338, which for the area that I was given is 93.5 square units. So this describes a borderline situation. So if we would take this dimension and divide it by this dimension, then we would get 8.26 divided by 11.3 equals, you get this decimal right here. And so if I take this decimal and multiply it by another number that I want to be one of the dimensions, then I should get the other dimension. So if I did that times, let's say 7, oops, so that times 7, I would get 5.12. So if we go to GeoGebra, here I'm going to move this graphic out of the way because we won't, oops, not that one, because we won't have to see that one. No, I'm going to need that one. No, I won't. I'm going to need that one. There we go. Okay. So if we change, what was it? The paper height was, what did I say, 7? Okay. So 7, oops. We make this 7. Let's go as close to 7 as humanly possible. And then take the other dimension, which I multiply by the decimal, which is 5.12. 5.12. Okay. There we go. That's close enough. Then we should be able to see where if we move this side to where the combined volume, which is the y-coordinate of Q, and the combined max volume of K prime, which is this right here, to be this relatively the same, then we get a borderline situation. So that's these two numbers right here. So if I move this, oops, not like that. So if I move this side, then you can see where the max volume is for the side. So if I move it, as close as I can get it, about there. No, right there. So you see that these two numbers are pretty close in value. So this is a borderline situation. So what I found that also relates is what could be, I guess, classified as a borderline situation. So I tried to find which two dimensions would equal approximately this square units. So if I took 8.26 times 11.3, then like I said, we got 93.338. But if I notice that if we go within 0.02 of each one, then we get roughly the same square units as we got here. So if I did 8.28 rather than 8.26 times 11.3, then we get roughly the value of the squared units of the area. So on the other side, if I do 8.26 times 11.5 instead of 11. Oops, no, that's not what I meant. If I do 8.26 times 11.32, which is 0.02 difference between what it was before, which is 11.3, then I get, once again, relatively the same area as I did before. So therefore, an easy way to determine the dimensions of a paper that have a borderline situation is to be within zero point zero 0.02 units of one of the dimensions, so rather this units or this units.